Imagine a world without smartphones, laptops, or even pocket calculators. That was the reality before the transistor. Electronics relied on bulky, inefficient vacuum tubes. These glass tubes, often as large as light bulbs, controlled the flow of electricity. However, they had serious drawbacks. Vacuum tubes generated a lot of heat, like tiny ovens within electronic devices. They were also fragile and prone to burning out, much like old-fashioned light bulbs. This made early computers massive, power-hungry, and unreliable. Clearly, a better solution was needed. The world was on the cusp of a technological revolution, waiting for a breakthrough. Little did anyone know, a tiny device would soon change the course of history. The path to the transistor began with a curious observation. It was a journey that spanned decades and involved the contributions of many brilliant minds. Thomas Edison, the famed inventor, noticed something unusual in his incandescent light bulbs. This observation would lay the groundwork for future innovations. A current seemed to flow between the heated filament and a separate metal plate inside the vacuum. This was more than just a quirk, it was a phenomenon waiting to be understood. This phenomenon, later known as the Edison effect, hinted at the possibility of controlling electricity in a vacuum. It was a small but significant step towards the development of electronic devices. John Ambrose Fleming, a British scientist, built upon Edison's work. He saw the potential in Edison's discovery and took it further. He invented the Fleming valve, also known as the vacuum diode. This invention was crucial in the evolution of electronics. This device allowed current to flow in only one direction, acting as an electronic switch. It was a breakthrough that paved the way for more complex electronic circuits. Meanwhile, another intriguing development was taking place. Scientists were exploring the properties of semiconductors, materials that would become the foundation of modern electronics. Early radios used cat's whisker detectors, crude devices that relied. Semiconductors, unlike metals, are not good conductors of electricity. Metals, such as copper and aluminum, allow electrons to flow freely, making them excellent conductors. However, semiconductors have a unique property that sets them apart. Nor are they perfect insulators. Insulators, like rubber and glass, prevent the flow of electricity entirely. Semiconductors, however, occupy a fascinating middle ground. Materials like germanium and silicon fall into this intriguing category. These elements have just the right number of electrons to make them versatile in electronic applications. Their electrical properties lie somewhere in between, making them ideal for controlling electrical current. This ability to control the flow of electricity is what makes